Let's do it. So law of logs. The main thing I'm going to impose on you is these four. I think it's really important. I'm going to summarize. The first law is essentially if you have log of some exponent, I don't care what that exponent is, you can drop it down. So here's an example. Log of base 1000, right? And the question said star 99. Okay, I'm just trying to be annoying here. That can be rearranged, dropping the exponent down as a coefficient. That's what I mean. It's a very useful law. Welcome. Morning. Okay. So just mentally try to ingrain that. If you see an exponent, drop it down. You can do it. And there is a proof for that. Okay. Number two, it's a little messy. Number two, if you have a logarithm of a certain base that is not a 10, using your calculator, you can still solve it. What did I say the other day about how the calculator is useless if the log is not base 10? Like, why is that the case? Why can't we use the calculator? Yes. All right, the calculator, if you look at the button, it just says log, which means by default, it's base 10. Surprise, surprise. Did you know that if you have a log, let's say of base, give me a number, 4 and 5, okay? That is not something you can directly solve in the calculator. But this, there's a proof, actually equals a ratio of the log of 5 over the log of 4. So the log of whatever we inputted over the log of whatever the base is. What I'm saying is any log of an unusual base, non-10, can be rewritten with base 10 or any other common log. This is also equal to, there's another button in your calculator called ln. I don't know how many people encountered ln in their science journey, but it is a natural logarithm. It is basically log of a constant e, Euler's constant. You don't have to know it, I guess, if you haven't encountered it. But long story short, as long as the base of both logs are the same, you can rewrite it as a ratio. So log of 100 base 5 over log of 100 of 4. It doesn't matter. It can be rewritten using that. Was that your question?
I was just going to ask, does you prove all this, or if we were going to be able to?
We can, you and me can explore it, particularly in class. And this is very easy to prove, right? It's just, I can use any number and be like, it always works. So that, as opposed to a proof, we just call it a law, right? Because it always works. As opposed to this, I think I would have to break it down and prove that it's always the case. But it does require some manipulation showing that it is 10 to the power of something and blah, blah, blah. So let's look at that later once we're done the lesson, okay? Once again, my goal is to try to finish the main point of it so that you can study for your science, okay? Number three, another super useful one. If you have a log of something added to the log of something, and they happen to have the same base, you can actually rewrite it as a log of its products. Very, very useful. So for example, if we have a question like, okay, right here, let's just do it. Log of 50, so this is like on the back page or side page, I think. Yeah, example 3, letter C, right? Log of 50 plus a log of 2. Now, consider it. The base is 10. 10 to the power of what gives you 50? Is that something that you can solve using the without a calculator? No. How about log of 2? 10 to the power of what gives you 2? Can you solve that without a calculator? No. But using our law here, if you have the same base, logarithmic base, and it's adding, you can rewrite that as a product of the two independent variables, which is the log of 100. And suddenly, it's much easier to solve. 10 to the power of what gave you 100? The answer is 2, right? 10 to the power of what gave me 100? This is solvable, while this is not. So a very useful law. Can you use this on your quiz? If I remember correctly, it won't be to this extent, and you won't have to use any of the laws, except maybe this one might come in handy, right? Because you've done questions like this in your homework sheet. So if you use the law saying, hey, this is one of the log laws, I'm not gonna penalize you for that. But just know that whether you know 6.4 or not, the quiz is very doable. Okay? In the same breath, product, quotient, same idea. Instead of an addition, if the logarithms with the same base are subtracting, you can write it as a single log with a division of the x and y. Okay? Here's an example. How about I do A and B, you try C, D on your own time. I try A and B, you try C and D on your own time. I try A and B, and you try D on your own time. I try E and F, you try the rest on your own time, blah, blah, blah. Okay? Let's try to get through as much as possible. Here we go. Evaluate log base 3, 9 to the power of 4. Yes, question. Yes, go for it. So a question like this, I see so many numbers. From here, my goal would be to solve, and again, let's try to use without a calculator. I am going to rewrite this by dropping down the exponent immediately. And then suddenly this becomes a lot easier to solve, right? With a base of 3, 3 to the power of what gave me 9? That would be 2. So the answer to this is just 8. No calculators. Yes?
For that, I did I switched whatever the base, but I changed 9 to 3 to the power of 2 instead.
Yeah, that works. Yeah, so log 3 squared to the power of 4, which is log 3 to the power of 8. And this is very similar to a question you had in your exercise sheet. 3 to the power of what gives me 3 to the power of 8? Well, the answer is 8. So it's exact same. Absolutely. Okay? Same thing here. If you want to do it that way, you can. I'm just going to force the exponent law anyways. Okay? If you have an exponent inside the log, just drop it down immediately. You don't have to, but that would be my first gut reaction. Most of the time it helps. Sometimes, rarely, it does help to keep the exponent up top because it helps simplify something else. But we'll get to those questions when we get to the harder ones, right? So 5 times 2 to the power of what gives you 8? It's a 3. The answer is 15. And I don't know why I'm writing with ink. I thought I saw a hand. Hannah, was that a hand? Yes.
My calculator can do the log with a different base than that.
So should I assume that it can and show you the word? Or can I just do it on
It would be nice on a test. Like on a quiz, you don't have your calculator, so it's whatever. But it's a very good question. Let me get back to you. Okay. Speaking of calculators, if you do have an accommodation for calculators, you're gonna have to bring like a rucked up dollar store can only multiply, divide, add, and subtract calculators for like $2. Okay. I think you know what you're talking about. I mean, what I'm talking about. Let's get going. Evaluate. Correct through 3 decimal places. So here is something where, you know, unless you have a special calculator like Anna has, you won't be able to solve it. What I would expect is you employ your log law and say log 17 of a base 5 is the same as log of 17 over a log of 5. That's it. And then you use your calculator afterwards. Okay. Or if you want to be, you know, super fancy, you can use the ln button too. It doesn't matter. You'll get the same ratio. And the answer is, someone help me out.
1.760.
Pardon?
1.760.
760. Yeah, let's do about. And I think that makes sense. How do I know? Well, 5 to the power of 1 is a 5. 5 to the power of 2 is 25. 17 is somewhere between 1 and 2. Sorry, 17 is somewhere between 5 and 25. So the exponent must be between 1 and 2. Right? I hope that makes sense. Okay, and we'll try here. Ooh, log of base half. Interesting. That doesn't matter. If you see that the numbers do not seem to match very well, you can just say log of 10 over log of 0.5. Or you can use ln or whatever. And in doing so, you ought to get some fairly large number. Harry, could I ask you to do it?
Negative 3.32.
Everyone else confirm? A negative log of this over. Yeah, that makes sense. That makes sense. Log of 0.5 should be a negative. Great. And that's it. Of course, the questions can get harder. So let's make sure we are comfortable using these in simpler situations, okay? Without being asked what to use. You need to be able to identify what you think is best. Here we go. Simplifying. Something like this. Immediately, I see the bases the same, and I see a subtraction. I am going to use that quotient law. That is a log 3 of 135 divided by a 5, which is log 3, base 3 of 27. Hey, what do you know? 3 can be used as a base to get 27. 3 to the power of what gives me 27? Remember my little spiel about you should recognize some numbers? 3, right? This is what I mean by, you know, not taking too long when you see familiar numbers. Okay? And here, instead of a division, it's a multiplication. It's the same stuff. E, F. Oh, let's do F. So here's one level up. What do you do when you have all 3? Well, I'm going to do it in a step-by-step way, and then I'm going to do it in, I'm confident in my laws, I'm just going to do it in one-step way. Okay? The step-by-step way is, oh, I see the base is the same. I can rewrite this as log base 6 of 108. Right? And that is being subtracted by log base 6 of 3. Wait a minute, they are the same base again. And so that's going to be log of base 6, 108 divided by 3, which is going to be 36. And once again, 6 with 36, it should raise a flag saying, hey, wait a minute. 6 to the power of what is 36? The answer is 2. But while you're copying this, I also want you to think about what we did with 54, 2, and then a 3. Inside the logarithm, we have 54 times 2, and then whatever my answer was, I divided by 3. By BEDMAS, the order doesn't really matter. We can simply, if the terms have the same logarithmic base, you can do all of that in one go. Okay? Because there's an addition and a subtraction, it's the same thing. So I hope you feel confident in doing this in one step, and at the same time, you don't make a mistake just because you see 3 terms, you're going to add it up. The base has to be the same. Okay? The logarithmic base has to be the same if you want to use this law. Please just make sure you confirm that before you jump right into it. Okay, so with that, I am curious to see what you will do with G, H, and I. Please note, log, I'm going to help you out with this one. Log base 6, 6 times square root of 6. That is the same as 6 to the power of 1 times 6 to the power of half. This can be rewritten as 6 to the power of 3 over 2. Okay? Just giving you a heads up. Don't think that this is weird. Think about it as exponents and logarithms. Okay. Any questions so far? Yes?
For example, for G, because we have 3 and half, so it should be 3 multiplied half log 8, 2 multiplied 2 over 16.
3 multiplied by, say again?
A half.
Ah, you're wondering, are you supposed to multiply coefficient with coefficient and then deal with the logs? That's not a bad like logical deduction. However, the law is very, very strict. Do you see any coefficients here? No, which means you can't have coefficients. Okay, does that mean we're stuck? Is there a new law? No, I'd like you to get creative. What is one way, just take a minute, really think about this. What is one way, there's no equal sign, okay? It's not there, you can't divide or something, you can't divide out. We have to put these coefficients somewhere. That's my hint. How would you solve that? I'll give you a minute. You're not removing the coefficients, you're just putting them somewhere else so that you can use the log for your benefit. Okay? Okay, let's pause this video and let's see what you got. All right, let's do it. So this is the hint. The hint is, what was it? X to the power of m. When you have an exponent, it can be dropped down as a coefficient. That means the reverse is also true. If you see a need to use one of the log laws, but the coefficient is getting in the way, you are allowed to manipulate it in this way. What does that mean? Well, log base 8 of 2 is a little hard to solve, okay? But look at this one. Log base 8 of 8 plus log base 8 of 4. 2, 8, and 4 are fairly easy numbers, and I would expect that you'd be able to multiply them all, right? 2 times 8 times 4, because they are all adding, which gives you log of 64. And that, a to the power of 2 equals 64. Okay? That's it. So I think example 4 is very similar to that. It's just I give you a bunch of variables and whatnot. I'd be more than happy to fill out the answer key for this and put it up online. I think the one that I have right now isn't complete. But in any case, let's quickly jump to example 5 and 6 to see what you would do and given, I guess, A or even T questions. And then we'll call it a day. Please jump to the very end. Example 5. Prove, aka show, that this left side expression is equal to just m using your log laws. Okay. And then number 6, it's a question very similar to what you might have seen before. Given log 5 of base 2 is some weird decimal, can you simplify and solve log 20 of base 2? I'm really greedy in that I want you to try it first. So if you're willing to spend some brain power this morning just to try these and make an attempt, I'll give you 5 minutes. We'll take it up and we'll end this today by 45. I promise. Okay? Give it a shot. All right, let's see it. The very last example, show that this equals that. I mean, if this was some kind of proof, I could see that there's no logarithm on the right side. So I'm going to try something. That m right now is an exponent. Here an m is a normal, I guess, real number. Okay, just some constant, I suppose. And so I am going to turn that exponent into a coefficient by quote unquote dropping down the exponent. So left side. So I hope you see it. The exponent, I treated it as one term, one object. I dropped it down as a coefficient. All I'm left with is log x of base x. Everyone knows that if we were to define it, equals 1, or if you need the proof, or if you need a law, it is in your equation sheet, which gives you m minus 1 plus 1 equals m. That is right side. Okay, so the trick here was just there's an exponent within the logarithm. Turn it into a coefficient. That's the first law we learned, the power law. For a second, let's go fast. Log 2 of base 5, and the question is log 5 of base 2, and the question was log 20 of base 2. Seeing how the bases are the same, maybe we can use one of the product or quotient laws. And I think that is the way to go. Log 20 of base 2 can be rewritten as log 5 times 4 of base 2. And I'm intentionally forcing the 5 in there because I think I'll make use of that. This can be rewritten as log of base 5 of base 2 plus log 4 of base 2. Log 5 of base 2 is given to me, and log 4 of base 2, you can do it in your head. 2 to the power of 2 equals 4. This answer is 2. The final answer is 4.3219. Just little puzzle questions for you. As promised, the lesson is over. It's now 9:45, so I'm going to let you go. The handout has a whole bunch of questions you can practice, but I imagine your priority is somewhere else right now. Please don't leave this until last minute, though. Please make an attempt at these questions over the weekend, or at least even Friday, okay, once all your deadlines are over. When we get back together on Monday, it is your quiz of 6.1, 2, and 3. Do not underestimate it. Okay. We would call it a mini test, but I think it's still a quiz. Just make sure you have practiced. Yes.
Can we scroll back to example 5?
Sure. Okay. Any questions? All right, let's stop the video and I'll start processing.